Imagine this. The entire history of Earth condensed into one calendar year. From the fiery birth of our planet at midnight on January 1st to the present moment, a mere 365 days later. Now, think about when humans appeared on this timeline. Surprisingly, we don't make our grand entrance until 10:50 p.m. on New Year's Eve. That's right, we've only been around for the last 70 minutes of this metaphorical year. What does this mean for our future? What thrilling or terrifying events lie ahead that we might never witness? To understand our place in this vast timeline of Earth, let's first consider the appearance of life. Life began stirring on Earth around February 26th, well over 1 billion years ago. Simple, single-celled organisms emerged in the primordial oceans, gradually evolving into more complex forms. By October, multicellular life had taken hold, leading to the Cambrian explosion around November 18th, which saw a rapid diversification of species. Fast forward to December 25th, Christmas Day, and we see the extinction of the dinosaurs, marking the end of the Mesozoic era. This perspective highlights how recent human history is in the grand scheme of geological time. Looking ahead, what significant events could shape the future of humanity and our planet? One potential hazard that caught the world's attention was the asteroid Apophis. Discovered in 2004, Apophis initially seemed to pose a real threat, with scientists predicting a 2.7% chance of it striking Earth on April 13, 2029. This asteroid, over 1,000 feet across, had the potential to flatten entire cities, causing widespread panic and concern. However, further observations have since reassured us that Apophis will pass within 32,000 kilometers of Earth, closer than some of our satellites, yet it poses no direct threat within the next century. This incident underscores the importance of vigilant astronomical monitoring. One of the darkest chapters in recent history was the Chernobyl disaster in 1986, the worst nuclear accident the world has seen. The reactor meltdown released a massive amount of radioactive debris into the atmosphere, rendering the surrounding area uninhabitable. This exclusion zone, spanning over 1,000 square miles, remains heavily guarded to prevent exposure to harmful radiation. Scientists estimate that it won't be safe for humans until around the year 22,000. The long-lasting effects of this disaster, including health issues and environmental damage, remind us of the profound impact human actions can have on our environment and the critical need for stringent safety measures in nuclear energy production. In the realm of space exploration, the Voyager space probes, launched in the 1970s, are on an epic journey beyond our solar system. These spacecraft have provided us with invaluable data about the outer planets, revolutionizing our understanding of the solar system. Voyager 1, the furthest man-made object from Earth, is now just 22 light-hours away. In the year 40,000, Voyager 1 will pass by another star. If an alien civilization were to intercept it, they would find the Golden Record, a message from Earth containing sounds, music, and images, along with a pulsar map to locate our planet.
After holding detailed reviews to understand the in-flight anomalies,
this gesture symbolizes humanity's desire to reach out and connect with the cosmos, showcasing our creativity and curiosity. Closer to home, Earth's magnetic field undergoes periodic reversals roughly every 300,000 years. The last reversal, known as the Bruns-Matuyama reversal, occurred 780,000 years ago, suggesting we are overdue for another. When this happens, the magnetic poles will flip, potentially exposing us to increased geomagnetic storms and global power outages. These storms could disrupt satellites, communication systems, and power grids, highlighting our vulnerability to such cosmic events. The potential impacts of a magnetic field flip underscore the dynamic and ever-changing nature of our planet, reminding us to be prepared for the unexpected and to advance our understanding of geomagnetic phenomena. Among the most spectacular cosmic events are supernova, the explosive deaths of massive stars. Two stars in our night sky, Antares and Betelgeuse, are nearing the end of their lives and could go supernova within the next million years. When they do, the afterglow will outshine the full moon for months, visible even during the day. Historical accounts, such as Johannes Kepler's observation in 1604, remind us of the awe these events inspire. Future generations may witness such a breathtaking spectacle, connecting us to the broader universe in a profound way. These events provide a glimpse into the life cycle of stars and the dynamic processes that shape our galaxy. Reflecting on human achievements, the footprints left on the moon by Neil Armstrong and Buzz Aldrin in 1969 are an enduring symbol of our quest for exploration. These marks on the lunar surface will persist for millions of years, only fading due to micrometeorite impacts. Unlike on Earth, where wind and water erode such marks, the moon's lack of atmosphere preserves them as a testament to human ingenuity and courage. This serves as a reminder of our brief but impactful presence in the cosmos and our relentless drive to explore and understand the universe, leaving behind evidence of our journey for eons to come. Saturn, known for its stunning rings, will lose them at about 100 million years due to a process called ring rain, where icy rocks are pulled into the planet. These rings, made of countless small particles, are gradually being drawn into Saturn's gravity. While this signifies a loss of one of the solar system's most beautiful features, Mars is set to gain rings. In 40 million years, its moon Phobos will break apart due to tidal forces, forming a new ring system around the red planet. This transformation highlights the ever-evolving nature of our solar system and the dynamic processes that shape planetary bodies and their features. The threat of catastrophic asteroid impacts is a sobering reality. 66 million years ago, a massive asteroid struck the Earth, leading to the extinction of the dinosaurs and drastically altering the course of life on our planet. Similar events are expected to occur every 250 million years. Humanity's challenge will be to develop technology to detect and deflect such threats to ensure our survival. By advancing our space exploration capabilities and improving our understanding of asteroid trajectories, we can better prepare for and potentially prevent these devastating impacts, safeguarding future generations from the same fate that befell the dinosaurs. Gamma-ray bursts, GRBs, are among the universe's most violent explosions, emitting as much energy in seconds as our Sun will in its entire lifetime. A nearby GRB could wreak havoc on the Earth's biosphere, potentially triggering mass extinctions. Scientists believe a GRB 440 million years ago caused significant atmospheric changes, leading to an ice age and a major extinction event. This possibility serves as a stark reminder of the universe's power and unpredictability. Understanding GRBs and developing ways to mitigate their effects are crucial for protecting our planet and ensuring the longevity of life on Earth in the face of such cosmic threats. In a more distant future, our Milky Way galaxy is on a collision course with the Andromeda Galaxy. In about 4.5 billion years, this cosmic event will create a new galaxy, Milkdromeda. The merger will ignite star formation and transform the night sky into a dazzling display. Despite the chaos, this cosmic dance will be a testament to the grandeur of the universe. As stars and planets are flung into new orbits, the night sky will change dramatically, offering a spectacular view. This event highlights the dynamic nature of galaxies and the ongoing processes that shape the universe. As the moon gradually drifts away from Earth, our days grow longer. When Earth was young, days lasted just 5 hours. Now we enjoy 24-hour days. But in 4.5 billion years, a day will stretch to 43 hours. This slow but steady change illustrates the ongoing interplay between Earth and its moon. The moon's gravitational pull affects our planet's rotation, gradually lengthening our days. This phenomenon demonstrates the long-term impacts of gravitational interactions in our solar system and the evolving nature of Earth's relationship with its satellite. In about 5 billion years, our sun will exhaust its fuel and become a red giant, eventually consuming the inner planets, including Earth. It will then shrink into a white dwarf, marking the end of its life cycle. This inevitable fate of our sun is a poignant reminder of the finite nature of even the most enduring cosmic entities. As the sun transforms, it will dramatically alter the solar system, engulfing nearby planets and reshaping the remaining celestial bodies. Understanding the life cycle of stars, including our sun, provides insight into the future of our solar system and the broader universe. Looking further ahead, the universe will enter the degenerate era in 100 trillion years, characterized by the end of star formation. The cosmos will be dominated by black holes, white dwarfs, brown dwarfs, and neutron stars. As these remnants cool and decay, the universe will grow ever darker and colder, leading to the black hole era. This final stage, trillions of years in the future, represents the ultimate end of all stellar activity. Understanding these distant future events highlights the long-term evolution of the universe and our place within it, reminding us of the impermanence of even the most stable cosmic structures. While humans are unlikely to witness these far future events, our quest for knowledge and exploration continues. Whether through advancements in technology or the discovery of new scientific principles, humanity's journey is far from over. As we navigate the challenges and wonders of our universe, we remain a small but significant part of a much larger cosmic story.